All right, good morning, Math 42. I have promised both students in my in-person and online that I would create a walkthrough for this particular problem. Kind of a neat problem, involves some creative problem solving. It's a little, in my mind, it's a little hampered by the fact that there's this given equation that came from calculus. So it doesn't feel, for me, 100% totally earned, but it does rely on this thing. So a little setup is just this reddish line, this rust-colored line is the length of a ladder. And the question is, how long can it be to fit around this corner? And given that these hallways are 3 feet wide and 5 feet wide, going around a 90-degree angle. And there's given information too that you can define 3 times the secant of theta would be that length. But just to give a real quick explanation of that, if we consider that hypotenuse 1, just of the smaller triangle, and this hypotenuse 2, notice that the length of the ladder, that would basically be the 2 hypotenuses add together. And as far as this setup, if you wanted to say the secant of that angle, looking at the top triangle, this length right here would be the adjacent side, which is also 3 feet. So the secant of that would be the hypotenuse divided by 3, and multiply both sides by 3, which is how you get the 3 secant of hypotenuse would be that h1. And by a very similar argument, in this triangle, this 5 would be the opposite side. So if you related the opposite side to the hypotenuse 2, with reference to that angle, it would be the cosecant of that same angle would be h2 over 5, the hypotenuse, the flipped sign, right? The hypotenuse divided by opposite. And so that would make this length be 5 times the cosecant of theta. So in the end, that's our h2. So we could think of the ladder length as 3 secant of theta plus 5 cosecant of theta. All right, and we're going to put a pin on that. We'll come back to that in a bit. We're not going to use that until the very end. They give you this additional part of calculus delivered this sort of equivalency, the 3 times the secant of theta, tangent of theta, minus 5 cosecant cotangent. I'm just going to change this a little bit. I'm just going to add that 5 cosecant of theta, cotangent of theta to either side. I don't need to do that, but and I'm going to write what that results in. And for me, that just helps to see this a little better. Instead of having these 3 terms with 0, the 0 ends up not ever doing anything as you multiply and divide. So it's kind of doesn't need to be there. So I'm going to write this as 3 secant of theta times the tangent of theta equals 5 cosecant of theta times the cotangent of theta. It's positive because we added it to either side. Okay, so I'm going to kind of pick it up here. And most students, that whole first part, they got it. They were like, I'm fine on that. It's part 2 that I need help. So I'm going to do this all in one move. And what I'm going to do is I'm just going to divide both sides by this whole thing, everything except the 5. And the reason I'll do that is just so I can do this, such that the only thing left on this right side is going to be 5. And on this other side, we're going to kind of put all the information together. Okay. The right side is going to be very, very simple. This all works out to just be 5. But what I'm going to do now is just zoom in on the left side because I'm about to do a lot and I'm going to erase and stuff. I tried to do a handwritten version of this, but there were so many steps. And to me, it seemed difficult to read. I'm going to rewrite this. Well, I'm just going to rewrite this exactly as we see it. 3 secant theta tangent theta all over cosecant of theta times the cotangent of theta. And then I'm just going to do one big multiplication. The thing that will cancel out these terms in the bottom, the inverse of cosecant is the sine, and the inverse of the cotangent is the tangent. So if I multiply top and bottom here by the sine of theta times the tangent of theta, that effectively I'm gonna do that top and bottom. Eliminates the cosecant, or turns these both into 1. And eliminates the cotangent, turns both in these 1. And so now we have this long line of things, but I'm going to change, when I rewrite this, I'm going to do 2 things. I'm going to put the 3 out in the front. I guess I'm going to do 3 things. I'm going to keep calling that the sine of theta. But I'm going to rewrite the secant of theta instead as 1 over the cosine of theta. And so that sort of is, we've accounted for this, we've accounted for this. We've got this tangent theta times tangent of theta. I'm going to call that the tangent of theta squared, which we write with a square kind of between the 2 terms. It's just kind of how we do it to make it clear that it's not the theta that's being squared, it's the tangent function that's being squared. And the other thing I want you to notice is when this multiplies sine and cosine, that's actually just another tangent. When you multiply it, if we put the sine on top of that fraction, that would be another tangent function. So this all simplifies to be 3 times the tangent cubed of theta equals 5. And now we're in a position where we can actually solve this using the arctangent function, which just involves one more step before we do that. So what we have here now is that the tangent of some angle cubed is 5/3. And to solve for that number, we would use the arctangent. I'm sorry, there's one other thing we have to do first. My bad. We have got to take the cube root of either side. Then we can use the arctangent. This is going to be the tangent of theta equals the cube root of 5/3. And recall that you can find cube root. You can also call that 5/3 to the power of 1/3, which on my calculator, it's easier to type it that way. So I'm going to do parentheses 5 divided by 3 raised to the power of parentheses 1 divided by 3, 1/3. And that's going to give me a number for that the tangent of theta, I'm going to write approximately equal to 1.1856. And now, finally, I can say, well, all right, we can solve for what theta is using the arctan function. So I'm going to choose arctan of the answer. This is going to be with the unrounded 1.185631101. And I've got to take this out of degree mode and put it into radian mode. Actually, I could do it in degree mode. Just so you know, that came out to be about 49 degrees, but I'm going to change that to radians just because it's generally better practice for physical function. 1.1856. And I'm just using 1.1856 now because it disappeared. So this is going to be theta. Theta equals 0.8701. So that's the first part. Remember, the 2 things we wanted to answer were the ladder length and theta. We found this. The ladder length is going to be 3 secant theta plus 5 cosecant of theta. So I'm just going to write that as 3 secant of 0.8701 plus 5 cosecant of 0.8701. And my calculator may have secant and cosecant buried something, but for me, I would call this instead 3 over cosine of 0.8701 plus 5 over cosecant of, I'm sorry, not cosecant, sine of 0.8701. And then this is something I can enter in my calculator. 3 divided by cosine of answer plus 5 divided by cosine of answer. And depending on your calculator, whether or not it follows order of operations, mine does. Oh, I entered the wrong thing real quick. I entered cosine twice instead of sine in the second thing. Change that. Oh, I did something wrong. 3 over cosine of the answer plus, oh, I got it. I gotta retype this. Type this correctly and you'll get it. And you'll get it all good. 3 divided by cosine of 0.8701 plus 5 divided by sine of 0.8701 gives you 11.19. That's what I'm looking for. And that is in feet. And that's the length of the lateral. All right, as promised, I said I'd follow up with this video, and I did. See you soon.